Questions on page 495. Questions on 495. Phoenix, hurry up, find out about it and close it.
31.
31.
The pilot told officials he was flying in the Macon area and eventually experienced engine issues.
Problem 31.
Imagine there being your field,
You crouched right next to Larry Davis' house.
On problem 31, they said that you had your choice. Whether you wanted to use the chart or the null hypothesis stuff. Which way do we want to do it? Do we want to use that chart to decide, or do we want to use the HO and HA?
HOHA.
HOHA? All right, so first thing on 31, and I'm not going to do this for you, so you're going to have to do it. You're going to have to figure out what R is, and that means you got to do what with those two sets of numbers?
Put them in a list.
Put them in your list. So grab your calculator. Ben, go to, I don't know if there's open list on down the road there. Put them in the list. Once you get them in the list, somebody tell me what you figure out R is. And I guess while you're doing that, I can do the HOHA, because they're the same for every single one. HO is rho equals 0, and rho is not equal to 0. That means we're going to be two-tailed, so I can start to draw this also. We're two-tailed here. We're going to have to find our T. Our T, I think it's R over, I gotta remember the formula.
1 minus R squared.
1 minus R squared on top over what? N minus 2?
Yeah.
Anybody find R yet?
0.623.
Yep.
So now we're going to use the T chart. So how about your chart also? Get the T chart out, not the other chart. The T chart, that's what we're using on this one. What's our alpha on this one so I don't have to go back and read the problem?
1%.
0.01, and our degrees of freedom, remember degrees of freedom is N minus 2 this time instead of that, so it's 6. So we want to look up 0.01 and 6 on the T chart.
3.707 and
3.707, is that right? Everybody agree with him on that?
Yep.
We plug in here for R and all the rest of this stuff. This is 0.623 over square root, and I would highly suggest that all of you are trying this on your calculator so that you can know that you're doing it right. 1 minus 0.623 squared over N minus 2. I'm going to go ahead and stick that in. That was 6, right? Somebody figure all that out for us.
1.968.
1.968. Anybody else get that? It's not what I got.
Well, I also didn't do 6.23
What'd you
squared.
get?
I did the what the R
What'd you get?
squared it gave me the calculator. So
Oh, did you?
And I got 1.95.
That's what I got.
yeah, mine's probably
Yeah, the R squared on the calculator, I'm not exactly sure. It's something a little different. Yeah, it might be part of it. We are going to use R squared somewhere down the road here. We'll talk about it. So it's 1.95. We look at that, decide whether to reject or fail to reject. Do we reject the null or fail to reject the null?
Fail to reject.
Fail to reject. And once we do that, then we write out our interpretation. Our interpretation is going to start off with 1% level of significance. That's the first part of the statement. Then we decide. Then we say, is there significant correlation or not significant correlation? Is the second part.
No.
So if we fail to reject the null, then what's that telling us? That there is not. So there is not significant correlation between, what did the problem say this time? What were we dealing with?
Vehicles weight and the braking distance.
So, weight
Dry surface.
of vehicles, I'm writing more than I have to here. Weight of vehicles and braking distances on, Sean's still mad about a couple of tests to go in, and he wants me to write out every single word on dry surface.
Well, it matters because the next problem's on the wet surfaces.
Let's do the other way real quick, because it doesn't take very long. I'm not sure why we did this way's longer, but. So if we're gonna do it the other way, then we have to take the absolute value of R, and we decide whether it's less than or greater than the number from our chart. We use the other chart. I don't have a copy of the other charts. Everybody know which chart I'm talking about?
Is it the one you gave us?
It's the one that, yeah, the last one.
This one?
Yep. There you go. I'll get it here. On that chart, what's our N this time? 8. 8. So we go down to 8, and it's 0.01, so it's point what?
834.
834. My slide switched on me. Next. So this is the number from the chart. Our R was 0.623, and the absolute value of that is just 0.623. Number from the chart is 0.834, is that what you said?
Yeah.
Is R less than or greater than that?
Less than.
Less than. If it's less than, then that tells us that there is not significant correlation between the two. If it's greater than, then it tells us that there is significant correlation.
We can choose between doing the two?
That's what the directions say. You know, those are the things right above a problem normally that you have to read through and. That I know most of you don't read through. I can't say a whole lot because I didn't read the whole problems because Sean just enlightened me that one of them was wet surfaces and one of them was dry surfaces. I ain't paying attention. I just went through and did the second problem, didn't pay attention that that's what it said. If you did this bottom part, if you did that, then we don't need any of this, we don't need this. But you still need this, and that.
So we don't need to write the HO and the HA?
Not if you're using the chart method. So if you're doing, if you're doing hypothesis testing, then we're doing it this way. If you're doing the chart way, you need this, and then these two things. I don't know that, this one is a little shorter because you don't have to do as much math, but you still have to find R and plug them all into your calculator and everything, so it's not that much shorter. Sean will probably like it because Ebersole won't be able to make fun of his curves anymore. Huh? Do what?
So you're making fun of his curve?
No, Sean doesn't have any curves anymore. He's slimmed down.
You did a good job. Now you can fit in front of That thing's terrible.
Other questions? Nope. All right, what we're going to do today, linear regression. Same. We're still dealing with the scatter plots and everything, but now we're going to learn how to draw the line of best fit. And this stuff should go really quick. This is pretty easy. This assignment, when I did it this morning, took me about 15 minutes. Huh?
So I like here.
Takes you about 5 minutes to cheat.
Yeah, it would've took me less time if I would've cheated. So, I mean, I could cheat all the time. I have an answer book back here somewhere. Don't be looking for it, Brendan.
What's he doing? Look for it, Brendan.
He just decided to sit back here.
Take pictures of it.
He's probably on his phone. He's probably sitting back. I'm just kidding, Brendan. I'm just kidding.
Gotta wish him.
I believe you are. Today you seem like you were with it today. Find the equation of a regression line. So we're actually going to make our scatter plot. It might look something like this. That's my scatter plot. And then what you're going to have to do, and I'm not going to make you draw the line perfectly, but some of the problems are going to say draw a line of best fit in here. What you want to try to do when you're drawing a line of best fit, you want to try to hit as many points as you can, and you want to try to keep as many points on this side of the line as that side of the line. All right, now there's an actual line of best fit that's going to fit in there that you could graph on your calculator and everything, and we're not going to go through all that because it's a pain in the butt. So when they ask you to draw it, just draw something like that. So if on the test, this is our scatter plot, and you draw your line of best fit like this, then yeah, it's going to be wrong. Okay? So I'm not looking at that you're drawing the perfect line in there all the time, but you should have some idea where it goes. And then we're also going to predict y values. So once we draw this line, you're going to write the equation for that line. Blast from the past here. Y equals mx plus b. All right, we're going to write an equation in that form. Then once we write an equation in that form, so it might look something like this, y equals 2x minus 4. They're going to tell you an x, you're going to plug it in there, you're going to figure out what y is. That's making a prediction of what you should get. If x is this, what should y be? So if, and doctors do stuff like this, we talked about the babies. If the baby is 28 inches long, what should the weight be? And they can get some kind of idea off of that, and we could use it on any of the other stuff. The one that we just got done doing with the car, we can predict if the car weighs this much, what should the braking distance be? After verifying that the linear correlation between two variables is significant, and the problems on the homework, they tell you that it's significant. We don't have to verify it. They tell you, hey, these two are significant to each other. There is a significant correlation. Just go with it. That's what they tell you on the problems. I didn't give you any on the homework where you have to figure it out yourself. Then we can write an equation and draw a line of best fit, and that line is called the regression line. So the things I would write down there is just something, maybe a regression line. It's called the line of best fit. That's what we're dealing with. Don't look back here, Gage, when you hear me coughing like that, because I'm probably spitting up crap in the trash can right now.
Okay, yeah, we'll see that.
Dry it out. Yes, I did.
Okay, I would guess it's the same.
Crap like this, bro.
I know it's like.
I know it's 3 something.
I lost round one.
That your line of best fit can be used to predict the value for a given x. So if we come out here, let's say we want to know what this x is right here, then we come up to the line of best fit here, figure out that, and we can come back over this way and see what y is about. If you have the equation, then you can just plug into the equation. You don't have to try to look on the graph, but you can do either way. Bad thing with doing it this way, you can see my line went downhill a little bit, so as you're looking across through here, if your eyeballs are going downhill, then you're probably screwing up your prediction. Residual, this is important. We're not gonna do a whole lot with this. When I took this class at Wright State, this is one of the things that just killed all those other teachers. They hated this. Because that professor would give us a set of sample data that had 50 or 60 different pieces of data in it, and we had to find the residual values for every single one of them. And all the residual is if you're looking at a graph, if you're looking at a scatter plot, whatever that scatter plot looks something like that, and you have a line of best fit that comes through here, what the residual is the distance this point is from the line, 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 distance this point is from the line, so on and so on. You gotta find all those distances.
That doesn't
Seem terrible.
sound like
Huh?
That don't seem terrible.
It's not if you gotta do 8 or 10.
Ah, you have to do a
You
lot.
gotta do
sounds
50 or
monotonous,
60.
though.
Right, it's very monotonous. So there, what I had to do, we had to make the chart. You had your X, you had your Y. Sorry, I can't, it's not letting me write up there. Then what you had to find was you had to find the distance that each of those points is from there using the distance formula. And you just had to go over and over and over and do it for every single one of them. You found those distances. And then once you found all the distances, some of them are positive, some of them are negative. If your line of best fit is correct, just like earlier this year, if your line of best fit is correct, then when we add all those distances up, guess what they should add up to? They should add up to 0. All right? Because that line of best fit should be right in the middle of all of them. Well, you don't want 0. So what we have to do with each one of them is you have to take those distances and you have to square each one so you don't get 0. Then you add all of those up. Once you add all those up, then that's going to be our residual value that we're going to talk about here in a minute. We're not going to do all of that. We're going to let the calculator do it all for us. All right? But just so you know that, if you go off to college and you take this class, and don't call your professor an idiot or something because he or she makes you do it a certain way, because they may make you work it out longhand like that. Residual line, or line of best fit, we just talked about that. Line for which the sum of the squares, so the sum of all those squares is the very smallest amount. That's where that line comes from. Now, so when I was doing it in college, what I had to do is I had to find that residual value, and instead of knowing where the line of best fit was, because your calculator is going to tell you, we had to find that line of best fit. And that's what makes it more difficult.
Did you do that on stones or mud?
We had a stick and we wrote in the mud.
Ah, that's what I
But
was-
if we were inside, if we happened to be inside that day, we had little clay boxes that you could write in, and you'd wipe it and flatten it out.
In the cave? Inside?
Yeah, in the cave.
Was it the day like this sulfur was?
So what's that thing called? The counting toy? You move it?
Abacus?
Abacus.
How did you know that?
They used to have a picture of one on the wall here somewhere. I don't know what happened to
Did you think
that.
about an abacus for?
The equation of the regression line. Write down that equation. That first part's not y. What is it?
Why?
Y hat. So when we're doing this, it's y hat equals mx plus b. Now, I'm also gonna write this down. On your calculator,
What's this for?
it doesn't say mx plus b, it says y equals ax plus b. So a here is the same as m, and m is the slope of the line. It tells you how the line rises and runs. Hopefully you remember some of the things. If you have a line and it goes like this, what's the slope of it?
Negative.
Negative. If you have a line and it goes up this way, then the slope has to be a positive. All right, so make sure you remember that. If that a is a negative, then the line's going down from the left to the right. If the a is positive, it's going up from the left to the right. What if you have a line that looks like this? What do you know about its slope? It's positive.
It has no slope.
It's positive, but it also has a it does have a slope, but it has a very
Are you trying to make it
small
angle?
slope.
You trying
Yeah.
to make a little angle? I thought you could try to make a straight line.
All right, all lines are straight.
You meant a flat line.
That's something a doctor does. Oh, thank you, a horizontal line.
A
Then.
doctor just get flat.
That straight line you got there.
So, oh, I already had that written down. So slope on the calculator is A. Just make sure you know that so that you don't get it messed up. The y-intercept is the B. That's where it crosses the y-axis. The bad thing with the y-intercept is a lot of times our graphs look like this, and then we have that break here and this break here, and the line goes like this. Can you really tell where it's going to cross the y-axis at? Sometimes you think, oh yeah, it looks like it's going to cross here. No, it's because if this is a break here, you're smashing it in so much that you can't really tell. And the y-hat is your predicted value. Before you write this down, is everybody going to use their calculator?
Yes.
So that's how you find the slope, which is A on the calculator. All right. Let's see what else is on here. All this. You might want to write this down. Anything that's x subscript I, comma y subscript I, that's just any point from the original data, any point from the sample. There's supposed to be something else on this slide that's not there. Hold on 1 second. Oh, that's why. You might want to write this one down too. That's what I was looking for. If it says, I know it's hard to read now, this point, X bar, Y bar, whenever you're doing a line of, whenever you're doing a line of regression, there's going to be some point that has to be on that line in every single set of data, and it's X bar, Y bar. The mean of all the X's, the mean of all the Y's, that's a point that for sure has to be on the line of regression. And I guess that was up here, wasn't it? So X bar is the mean of all the X's, Y bar is the mean of all the Y's in the sample. Again, you're probably not going to care much about all of this stuff, because instead of us finding M and us finding B and doing all this by hand, the calculator is going to do it for you. What I want you to do now, get out your calculators, put those in a list. We're going to do two things together. So put this in like list 1, list 2. Then the second set, you're going to put like list 3 and list 4 or something. You handle that?
And 149, 141. Looks like that.
There's some way you can clear them all one thing. Anybody remember how to clear all your
Just
lists?
go up to L1 and just clear.
So if Gates said you can go to the top of them and press clear and it'll clear them, but there's some way to clear them all at once too.
Oh, I don't know how to do that.
Yeah, you go to every single one here. Clear them all.
It's something to edit and then it goes edit and then down, once you get down there, it says clear list or something, doesn't it?
Yeah, it's stat, and then it should be number 4, it's just clear list. Yep. Michael, would you, fix it? What?
Okay, are we doing that? You know what, tomorrow, right? Well, so tomorrow. Yeah, sure. All right. Cool. Meet up day. Meet up day.
I went to meet up yesterday. I live in Pepper's.
So we're gonna be here today. Are we going to one
Please
mission?
control your dog. That's what I know.
Thanks for keeping my company right
I
up.
think the problem,
Yeah.
when you go to this, see these up top here?
Hi, man.
And everybody might wanna listen to this. If you go to the Y equals button, and you see where it says plot 1, plot 2, plot 3 up top,
Yeah.
don't highlight those. If they're highlighted, if they're darkened in, that could mess up your stuff. Really?
You just click it
This is the
again.
only class and you send out an email anyway.
What class you up on? Brian?
So,
You click it
So
again.
you had a couple.
Look if it's highlighted.
yeah. So now, if I hit graph. Yeah, clear it now, but I used it just to see if it would graph a line,
I have to be
and
there.
it did.
Are
You can't see your Y-axis
Yeah.
because your screen's messed up.
Not supposed to read that.
more people speaking or is it just your?
This our group
And I did change I changed the window back to like 10, it's -10 or something, so you.
I don't know yet. We're gonna figure that out.
Yeah, we're gonna, during the meetup, I'll think about it.
At least.
Everybody got this in your list? So first thing we're gonna do the same thing we did last time. I want you to go to stat, calculate, and I believe it's like number 4 where it says linreg AX plus B. Make sure you're going to this one, there's another one on down. Don't look for it, cause then it's gonna confuse somebody.
I'm looking for it.
It'll get confused.
A plus BX.
So it's sort of backwards, we don't want that one. So go to that, type in whatever list that you typed in, L1, comma, L2. Somebody help me out and tell me what R is.
0.882.
882, everybody agree with that?
Yeah.
Tell me what A is.
196.15.
196.15,
Yeah.
and what's B?
102.30.
0.3,
Or 2.8, you know.
Or 2.9.
2-9.
29. We'll go with what we have. since our-
They didn't round the top one.
Yeah.
Oh, wait, never mind, I guess you did.
So we have that. If we want to find the equation for our regression line, it's just gonna be this. Y hat equals, what's our slope this time? Slope is the same as A, so we put in 196.15 times X. And what's our Y-intercept?
102.3.
So plus 102.3. 0.3. That's the equation of our line of best fit.
Seems pretty easy.
Now, what we can do with that is we can make predictions, and we're gonna do that here in a few minutes. We can make predictions like, let's say, Daniel Land, he starts his own country, and Daniel Land has a GDP of $2.6 trillion a year. All right? Well, we can stick in that 2.6 right here, and we can estimate how much CO2 emissions his country's gonna have.
Can you say trillion again?
Trillion.
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 He's saying it's water.
Trillion. The trillion.
Here's doing the chart.
What
It's
country
what,
has $69,000?
it's what Brendan's gonna be doing if he keeps messing with my mouse. We do all that stuff. Figure out what B is, figure out what M is. I know you guys wanna do all that. Sketch the graph, draw in the line of best fit.
This is all.
One more. Two others. Don't erase that one. Find two others and take a second and plug these into your calculator. Ben, you might try to use your calculator and see if it's working.
Alright.
If it doesn't work, then the lists are on my calculators, Notice, you guys want me to circle the X's or something so that you can tell? That all goes in as an X, that one goes in as an X. Then your Y's are here and here, so a little longer list.
Put it, both the X's in one list?
Yeah. All the X's in one list, all the Y's in another list. Do you remember your calculator, Michael, or did you just steal one?
This is mine.
Somebody on the roof.
The roof.
Wolf.
Apparently those guys back here don't know that if you live in glass houses, don't throw stones, right? That's a little too complex for them probably, so you live in hillbilly heaven here, don't be making fun of how I say words.
Yeah, Zoe.
My mom says crown.
I
It's not a crown,
Well,
it's
don't
a
get mad
crown.
until you go down.
I say crown.
I
mountains of Ohio, and that's where it's like real.
My dad says chimney. So
Where's the L in chimney?
So did my father-in-law.
Why?
Chimney.
I don't know.
Chimney? Get your guitar.
Yeah, he always stuck an L in it, then
People that say cricket.
He won't say. he
towards
won't
the
say
end of his
cricket.
life, my
He'll
wife
say
got on him about it.
washer. He says
And
washer the winder.
then he starts, it was
I
really,
still say, I said oil.
Is it creek or says
I
oil?
said oil.
at some point, I knew Chim Lee must have been
My
there.
dad telling me something.
I do actually.
My dad just really the real filters.
It's not a good
Fix
Quit coloring in my letters.
Everything.
Somebody tell me the equation. What's A this time?
Building?
12.480 or 481. For sure, well, that's
Times X, what's our B, Y-intercept, our B?
33.683.
Positive?
Yeah.
Yeah.
It's a positive number is what I meant, not,
Yeah.
are you sure?
Yeah.
No.
So that's our equation. Calculator tells you that. Somebody do me a favor and write it down somewhere on your notes there, because I think we're gonna need it. And we probably should have wrote down the last one too, because I can't remember which one we need for
I
this
did
next stuff.
write down the last one.
Thank you. Our R is right there if we wanna decide whether there is significant correlation or not. Our R is right there on the calculator. We can do the stuff that we did last time again. They're not gonna ask you to do that this time, but later on in the chapter, you're gonna have to do both. Calculator should look something like this. Is that what we said, 33.68 and 12.481? Our R was 0.978. If our R is 0.978, what's that tell you about the correlation?
Pretty.
It seems like it's a pretty good correlation, doesn't it? So they should be able to predict pretty closely. That's why it makes it even stupider that I was telling you about that guy out there that his buddies were filming him as he's sticking his head over.
What's Minitab?
Minitab's another computer setup. It's like a, you have to pay for it. And by now, it's probably nothing now because it's probably gone because our books are old. But Minitab went along with this book and you paid for it. And it's a setup on your computer where you can just type in the list and everything and it'll do all this other stuff for you. A little better than the calculators, but, so it's almost like an Excel.
The R's are supposed to be on there.
Your R's not on there? Let's see. Anybody remember what did we do last time?
Starts with a D, domain or something.
No.
Diagnostics.
Diagnostics, you gotta go,
It was 0, wasn't it? Second 0.
second, yeah, second 0, scroll down a bunch.
Why is she so sneaky? Is that what it's sneaky? It's just.
Diagnostics. Enter. Should work out.
Whoa, whoa, whoa. Look at what my arrows on, bruh.
Try to graph it real quick. How did we graph them last time?
What is this?
So you go to stat plot. That's like second y equals or something, isn't it? You go to on. Stat plot on, what after that? Yeah. On, what do we do after that?
You might have to change your window.
Oh, you gotta, so then it says that you gotta put the list in there, right? List 1, list 2, whatever list you put it in. And then maybe change your window, then graph. Graph is up top right and underneath the screen, is that right?
Yeah.
And then
Yeah, there we go.
might have to change your window. This one, you might have to make your Ys, since it started at 50 and went to like 100. All you might have to do is, the X is probably all right, the Ys, put minimum value 50, maximum value 100, something like that. And then you should be able to see it. Does your graph look like that?
Yeah.
Now, does your graph have the line of fit in it? It's just got the dots.
Literally press window.
What you could do, once you have this, and I don't suggest doing this, because I think it messes everything up. Once you have this and you have your
Just make some.
line of best fit here, I don't know that it'll mess everything up, we might be all right. You could go back to the Y equals and graph both of them at the same time, and it'll put the line in there for you. I think it'll do it.
Yeah.
So it's got both of them now?
Yeah.
So you can stick that in there too. And it'll show you where the line of best fit is at in that scatter plot. And you can look at it, and this one looks like it's pretty, everything's hugged pretty close to the line. We already did all this. If you wanted to write this down, you can. We already figured all that out though, right?
Yeah.
So that's to find A and B to write your equation. If you want to write it down, you can. I'll give you a second. That's so you can write your equation of the line.
Midnight, change that one like back and forward.
What?
I can get them over each other.
Get you figured out.
You put them on the same time.
I did it. It's kind of a process though.
Oh, is it on yours?
Yeah, cause I gotta like copy there's a button after I hit calculate to like copy it, and then it copies it to the graph section, and then.
The TIs weren't hard to get them both on there, was it?
You said what to do.
It just graph one right after the other and it works.
It seems like it when you do the stack plot, it makes it only like the plot boards that highlights the plot board. And then it backs it.
The thing you will have to remember is, now you got, on your graph, you got something under Y equals something. Make sure you go back and erase that, because now that line's on there and it's gonna stay on there. And then you do your next dot plot, or your scatter plot, and it messes, you know, it's gonna have that line on there, and Daniel's gonna look at it and go, that line doesn't fit that data, what's going on here? So you gotta make sure you get rid of all of those. Last thing, to make a prediction, all you're gonna do to make a prediction, we do something like this. If we know our X we want to predict on is 5, we're going to take that 5, stick it into the equation that you just wrote, and see what comes out as the Y. So whatever, I don't know, I just made up something here, I'm sure. Whatever the 5 was, 5 elephants. We're guessing that if you have 5 elephants, then you got 1.5 giraffes. We're making a prediction off of that. Again, you could make the prediction off of the graph. So if your graph looks like this and you got your scatter plot on here and your line of best fits here, you could make a prediction by just coming out here to 5, going up to here, and seeing what the Y value is at that point. But it's probably easier and more precise to plug into the equation. Then there's one last thing. When you're making a prediction, and make sure that you understand this, and when you're making a prediction, it's not a meaningful prediction if the X value is outside the original range of the sample values, sample X's. So if I'm looking at this, what that means, I look at all these X's right here, and I decide I want to predict what happens when X is 1, it's not meaningful. If it doesn't fall inside our original X's, it's not a meaningful prediction. So, if we set up a chart that goes 1910, 1920, 1930, 1940, 1950, and we have the price of a loaf of bread for all those 10-year things, all the way up till now, we cannot make a prediction. It's not going to be, we can make a prediction, I shouldn't say that, but it's not going to be a meaningful prediction to predict what the price of a loaf of bread is going to be in 2030. All right? Now, you see, math people say it's not meaningful, but on the news and stuff, you always hear, well, by 2030, this is going to happen. Well, that's not a meaningful prediction because you're predicting outside of what we actually know. All right? Math people take into consideration the fact that by 2030 or 2040 or 2050, people are going to be so stupid that they blow up the whole earth and we're not going to be here anyway, so the price of bread is going to be nothing. There's going to be no such thing.
It's very pessimistic.
So if I was going to predict, can't predict on anything larger than 35 or smaller than 5. I'm sorry, I keep saying that wrong. You can make a prediction on those. It's not a meaningful prediction. Not something that I would stake my life on. One of the things that I used to do when we did this, the world's population. And I think we watched the video at the start of the year. Remember that video we watched that showed the world's population? Well, if we made a prediction for like 2030 from what the information that they were giving us on that, the world's population, it was going like this. Well, by 2030, we'd be like up here somewhere. And according to the prediction that they had, we would be all standing like this because the whole earth would be packed full of humans. And we know that that didn't happen. So if we're going to make a prediction on this, I guess I had it written down. I didn't need you guys to write it down. All you're going to do with this 1.2 is what? Put it in there for X, and that's going to tell you the CO2 emissions for that for $1.2 trillion. Same thing for the 2.0, you just stick it in there for X. That tells you the CO2 emissions if your country, Daniel's country, has GDP of $2.0 trillion. So that one comes out to be 3.37 .671. Now, the other thing I want you to remember, because I think one of the problems on the homework, remember what these are in. One of the problems on the homework says it's in thousands of dollars. So if if this was in thousands here, what's that telling us that we could do with this decimal?
You're counting over 6 places.
How many places?
6, right?
Wait, hold up, I'm numbering.
Thousands. How many are zeros?
Yeah.
So on the homework one, I think it's talking about price of houses or something. Well, if you get this answer on the homework problem, instead of writing 337.671, the better answer would be $337,671. Because that makes more sense to whoever looks at it next, instead of changing it into thousands of dollars. So just make your answer so it makes sense to the problem and to other people who look at it. 2.5 trillion. We did that. Do that. So on and so on. Prediction values are meaningful, again, only if it's inside the predicted thing. That's your assignment.
Before